Hello everyone. In previous lecture we discussed that radioactivity counting instrument, that is GM counter, and in today's lecture we discuss second instrument used for measure the radioactivity power of radioactive element. That instrument is scintillation counter. This is that scintillation counter is combination of phosphor, that is scintillating material, and photomultiplier tube. This is combination of phosphor and photomultiplier tube. That scintillation counter has several advantages over the GM counter. We discuss later on. First part of scintillation counter is a photomultiplier tube. Photomultiplier tube is an electron multiplying device similar to amplifier. We know amplifier amplifies sound. In the same way, this photomultiplier tube multiplying electrons and works on the phenomena of secondary emissions. Photomultiplier tube works on phenomena of principle of secondary emissions. Construction of photomultiplier tube. It is long metallic tube having sensitive photocathodes at one end. Long metallic tube having sensitive photocathode at one end, and series of electrodes known as diodes arranged in the entire tube. Each diode is at higher potential, that is successively potential increases. Therefore, each diode is at higher potential than the previous diode, and therefore the electron beam traveling from one diode to other diode is continuously accelerated. That is electron beam amplification of that electron beam takes place. That is each diode, this one is important, each diode is at higher potential than the previous, and therefore the electron beam traveling from one diode to other is continuously accelerated. Then working of photomultiplier tube. When light enters in that light photon strike the photocathode, which is placed at one end of that photomultiplier tube. When light photon strikes the photocathode, then due to photoelectric effect, the electrons are emitted from that photocathode, and that emitted electrons travel to first diode and get accelerated. These electrons are energetic and produces secondary electrons at first diode. The beam of primary and secondary electrons then travel towards second diode, which is at higher voltage, and is further accelerated. Same process repeated at second and further dinodes, and thus electron current is amplified as beam travel from one dynode to another. Then second part of scintillation counter is main scintillation part, that is scintillation counter. Construction: it consists of phosphor enclosed in a metal chamber. Phosphor, which is here shown in diagram, that phosphor enclosed or coated in a metal chamber with reflecting surface. That phosphor have on their another coating on phosphor, that is reflecting material is there. The metallic chamber has a small transparent window on one side and light pipes on the other side. Then working of this photomultiplier tube. The radiations when enter through enter through the transparent window, and that produces scintillations. That radiations from photomultiplier tube enters in that when radiations from that radioactive material when enter through that window and strike on that scintillating material, that produces scintillations, and that scintillating radiations that are transported through that light pipe and incident on photocathode, that are incident on photocathode, first cathode of photomultiplier tube. Then in photocathode, we all know that in that tube, multiplication of that amplification of that signal takes place, and that photomultiplier tube produces signal which is directly proportional to that radioactivity power of radioactive element. Then type of phosphors used in scintillation counter. First is thallium activated sodium iodide. Thallium activated sodium iodide. This is most versatile and frequently used material as a scintillating material, and used for gamma radiation, counting of gamma radiations. Then disadvantage of this thallium activated sodium iodide is it is hygroscopic in nature. This one only disadvantage. Then second scintillating material is zinc sulfide. It is so very useful for measurement of alpha particle counting. Then another one is anthracene and stilbene. This one is used for counting of beta particles. Remember, for gamma radiations, thallium activated sodium iodide. For alpha particle, zinc sulfide, and for beta particles, anthracene and stilbene. Then the advantages of this scintillation counter. This one is available in variety of size and shapes, produces sharp pulse, sharp signals, better resolution time, no problem of dead time. That is as in a GM counter there is problem of dead time. Here no problem of dead time. Then disadvantage, it is heavy photomultiplier tube is required in this counter, scintillation counter, and at low energy the counter response is not 100%. This is about the scintillation counter, which may ask for 5 marks in question paper. Thank you.